Okay, let's do test H. Number one. Number one, this does, uh, if we were doing it by parts, we'd probably let u be this and then it would go to sine and we'd have to integrate sine to the third, which is not pretty, so probably not parts. It doesn't have a fraction, so it's not partial fraction. It's not a something squared plus something squared or minus something squared, so it's not trig sub. So this is probably just a table one. So I'm going to pull up the tables, and the most likely is 11 or 12. And I'm going to do it both with 11 and with 12. So you can see how they work. All right. So here's using 11, which reduces the power of cosine by 2. Well, that would go to minus 1. Seems like that might not work. However, if it's 1 and n minus 1 would be 0, this whole part would drop out. And so this is going to be really simple with number 11. So using number 11, I get sine with one more. So that'd be sine to the fourth x. Cosine 1 left, that'd be cosine to the 0, which is 1, over 3 plus 1 is 4, plus n minus 1, 0 over 4 times an integral. Doesn't matter what this is, it's times 0. And so we have this plus c. 1/4 sine to the fourth x plus c. That's the easy way to do this one. Not quite as easy way to do it is with 12. Now with 12, we have to do, with number 12, we're going to do minus sine 1 less, which would be sine squared. 1 less than 3 is 2. Cosine 1 higher power, so there'd be cosine, not 1, but cosine squared x over m plus n, which is again 4, plus m minus 1, so 3 minus 1 is 2 over m plus n, 4, integral of sine 2 less, which would be sine to the 1, cosine the same power, and then I can run this through 11 or 12, and that's going to make a fraction of 0 in the numerator, and this part's going to drop out. So let's say I just ran 12 again, then this part would stay the same. Plus 1/2, 2/4 is 1/2. And if I'm using 12, it's minus sine gets 1 less, so that'd be to the 0, so it's gone. Cosine gets 1 more, so it'd be cosine squared x over m plus n. In this case, it's 1 plus 1, which is 2, plus m minus 1. 1 minus 1 is 0 over 2 times an integral of stuff. This is going to be 0, and so we're going to get this plus a negative 1/2 times this, so it's actually going to be 1/4 cosine squared x plus c. Negative sine squared x cosine squared x over 4 minus 1/4 cosine squared x plus c. Now, we could have after using 12 and getting to here, we could have used u substitution for either sine or cosine here. Sine's easier to take the derivative, so if I said u was sine x, du would be cosine x dx. So this whole thing would change to plus 1/2 integral of u, and cosine x dx is just du. The cosines would cancel. If I solve for dx, I get du over cosine x, and replace that with du over cosine x, it cancels. And so we get this, and the integral of u is u squared over 2, and u was sine x, so I would get minus sine squared x cosine squared x over 4 plus 1/2 u to the 2, so that's cosine x to the 2 over 2 plus c. And it can be shown that this answer is the same as this answer, which is the same as this answer, using trig identities. So, multiple ways to take that one, but that one was mostly a tables one. Might have been able to do it by parts, but it would be pain. Okay. This denominator factors, and it also looks like a trig sub. There isn't a table formula that has x over something like this. And by parts, it might work, but that would be ugly. It's not really one set up for parts. So I'm going to do both of these, partial fractions and trig sub. I'm going to start with the trig sub, because I did this in class, and I, when we were going over this, and I went a long way around to doing it, and I realized I should have done something else. But anyway, it looks like we have to put 5x on here. This is the positive part of this. And the negative part, the 3, can go either place. In class, you guys had me put it there. And so the square root of 25x squared minus 9 would go there. In one of the classes, anyway, had me do it this way. So, x, 5x over 3, that's the not sine 3 over 5x, but the opposite, so it's cosecant theta equals 5x over 3 equals cosecant. Boy, I'm messing that up. And so I'll multiply both sides by 3/5, and so I get x equals 3/5 cosecant theta. Take the derivative, dx equals 3/5 derivative of cosecant, according to the table, is negative cosecant cotangent, negative cosecant theta cotangent theta d theta. So we've got x, we've got dx, and we need the mess, which is the square root of 25x squared minus 9. That over 3 is the cotangent, so it's 3 cotangent theta. Doing all the trig substitutions now, we have the integral of x, which is 3/5 cosecant theta. That denominator is the square of this, so that's 9 cotangent squared theta. And the dx is negative 3/5, and this is times, cosecant theta cotangent theta d theta. One of the cotangents cancel. So we get negative 9/25 divided by 9, so negative 1/25 integral of cosecant squared theta over cotangent theta d theta. And here I changed the sines and cosines, which was a mistake. This one's pretty easy to do if we let u equal cotangent theta. Cotangent's derivative is negative cosecant squared theta d theta, and that's going to cancel that cosecant. So this is going to turn into a negative, and a negative is going to be positive 1/25 integral of cosecant squared. This is going to have a negative cosecant squared. They're going to cancel, so it's just going to be 1 over u du, and the negative I've already brought out and changed that to plus. So that changes to the antiderivative of 1 over u is ln u. And u was cotangent theta, and cotangent, according to my picture, cotangent is this over 3. Okay. Partial fractions. The denominator factors to 5x plus 9 and 5x minus 9. And that's a linear factor, so we put an a over it. That's a linear factor, so we put a b over it. And so a would have to be times this, and b would have to be times this, and it would have to be an x. So we're going to get some x's in both of these, and there's one x here, so 1 equals 5a, just thinking in my head, 5x minus 9 would have to go times this numerator and denominator. And this would have to be 5x plus 9 plus 3. Boy, oh boy, oh boy, oh boy. 3. Factor that, it factors 5x plus 3 and minus 3. And so this would have to be times 5x plus 3. So I'm going to get 5a's and 5b's. And for the constant, which there is none, I'm going to get minus 3a plus 3b. I could take the second one and divide it by 3, and I would have minus a plus b equals 0. Then I could multiply by 5 and then add it to this one, and the a's would drop out, and I get 10b equals 1. And so b is 1/10. And if b is 1/10, this would be 3/10, so a would have to be minus 3/10, so a must be 1/10. So this would turn into the integral of 1/10 to the integral of 1 over 5x plus 3 plus 1/10, the b would pull out, integral of 1 over 5x minus 3 dx. And if I let u be that denominator, I get du equals 5 dx divided by 5. And this becomes 1/10, the integral of 1 over u du over 5. So I get 1/50th integral of 1 over u, which is ln of u, but u was 5x plus 3, plus, and the same thing's going to happen here, except for this will be the same with a minus there. Not going to change this part, and so it's going to be 1/50th ln absolute value of 5x minus 3. And that's an acceptable answer. How is this the same as this? Well, if you got two things divided, it's ln of this minus ln of that. Ln of 3 is a constant, so it could be taken over here, even times 1/25th. It still could be taken into the constant. So then we'd have ln of the square root of this. The square root is the 1/2 power. I can take the half down, and that would be 1/2 times 25 is 1/50th. And ln of that thing multiplied. Well, if we got two that are added, you multiply the insides, and that would make it 25x squared minus 9. So this answer and this answer are both correct. So this could have been done with either of those methods. First one was probably tables only. All right. Number 3. This isn't something we did with parts. This denominator factors, if you pull out as much as possible an x squared, that leaves an x plus 1. So looks like it could be done with partial fractions. And this is not something you would look for in a trig sub, and you're not going to find this in tables. So this is a partial fraction problem. So we have x squared, which we could think of as x times x, and if it's repeated, you do a over x plus b over x times x, the repetition, plus another linear factor. Or you can think of this x squared as a quadratic factor and do ax plus b over x squared. But if you put ax over x squared, you get this. If you put b over x squared, you get that. So I don't care whether you wrote this or that, you're going to get the same a, b, and c as I'm going to get here. What fouled some people up is they didn't go for the least common denominator. They said the common denominator is x squared times x plus 1. But you don't need x cubed times x plus 1. You just needed x squared. This would need to multiply by an x and an x plus 1. X times this would make it x squared, and times an x plus 1 would make it match. So x times x plus 1 is x squared plus x. Times another x would look like this. There's the common denominator. This has the x squared. All we need is the x plus 1 times x squared, which is what we had here. And this one needs only to be multiplied by x squared, because it has the x plus 1. So, no x squareds. We've got x squareds over here, so no x squareds equals a of them, none there, plus c of them. X's, none there. We have a of them plus b of them, and that's x squared, so that's it. And the constant, well, we have 2. And here we wouldn't get any x constants. Here we get b, and none there. So b equals 2. And if a plus b equals 0, a must equal minus 2. And if a is minus 2 and a plus c is 0, c must be 2. So this problem changes to -2 integral of 1 over x dx plus b, which is 2, and c, which is 2, and the integral of 1 over x is ln, so we get -2 ln x plus, this isn't ln of x squared, this is x to the minus 2. If you integrate it, you add 1 to the power and divide by that power, so you get 2 times x to the minus 1 over minus 1 plus 2 times antiderivative of this. If you let u be x plus 1, you find out that this is just 1 over u, so this is going to be 2 ln x plus 1 plus c. It's possible to clean that up, but that's good enough. And that's the only method that really works on that problem. This one doesn't look like parts stuff we've been doing. Doesn't like partial fractions because of that square root. It does look like a trig sub, and this probably is in the table, so we could do either one of those. We'll do trig sub first. And they're added, so I could put x in one or x in one the other way. But then leg squared plus leg squared, x squared plus 1 squared. Square root is the hypotenuse. So if I put theta there, x is opposite over adjacent, tangent is opposite over adjacent, so the tangent of theta is x over 1. So dx would equal, the derivative tangent is secant squared theta d theta. And the mess, 1 over the mess is the cosine, so the mess over 1 is, or mess is square root of x squared plus 1 over 1 is the secant. This over 1, secant. So this changes to 1's a constant. We can leave it. That is secant theta. And dx is secant squared theta d theta. And one of the secants cancel. And we have the integral of secant theta d theta. And the integral of secant is ln secant x tangent x. So we get ln secant theta, our variable is theta, not x, plus tangent theta, and ln of secant on this triangle, secant's not as a reciprocal cosine, so not this to this, but this to this, which is square root of x squared plus 1. Tangent is opposite or adjacent, so that's plus x. So there's doing trig sub. Now, there is a formula for that one. That could very well be done with formula 16. 16 says u squared plus a squared. We have x squared plus 1 squared. And in a square root and no other letters around, so it's just going to be ln of u is the x plus the square root of x squared plus the a is 1 and these look identical. We don't even have to do some arithmetic to make those look right. That's 4. 5. This does look like integration by parts, because in integration by parts, we tend to let u be something that'll get simpler when we take its derivative. And we let the rest be dv. And the antiderivative of secant squared is tangent. And the formula is uv, so x tangent x minus the integral of v du, which is tangent x dx. And as I said in class, several people said that antiderivative of tangent is secant squared. And that is incorrect. The antiderivative of tangent, the derivative of tangent is secant squared, but we want the antiderivative. And that happens to be on our page. Antiderivative of tangent is natural log of the secant of x. So we get x tangent x minus the natural log of secant x. And we're done. This one says, find the formula for a of x, determine this function a of x without an integral. So we need to integrate. Not to be confused with the ones that have derivatives of integrals or integrals of derivatives. This is just an integral. What is the antiderivative of t squared? What's the antiderivative of e to the t? Evaluated from 4 to x squared. So we put x squared in place of the t's, and we get x to the 6th over 3 minus e to the x squared, minus putting 4 in for the t's. 4 cubed is 64, but there's nothing that reduces. 3 doesn't go into 64 evenly. Minus and 4 in for the t there. And that's good enough for the answer. Seven. If we're going to integrate, we're going to put in the x into the antiderivative and 1, and then when we take the derivative, the 1 in it's going to disappear because that would be a constant. So and the derivative is going to take us back to this function with an x in it. So it's just going to be arc sine of x times e to the x. Now, if we took the derivative, whatever that is, and then integrate it, be back to this thing, and we got to put in x and put in 1. And since we're doing it, the derivative first, we're going to get both pieces. We're going to get x in place of the t's, minus 1 in for the t's. Arc sine 1, e to the 1. And finally, f of 0 is negative 4. F of 0 is negative 4. If I look at this area, that's 8 times 2 in half is 8. It's positive. This graph has to be going up. In fact, all this area is positive, so from minus 8 to 12, the graph has to be going up, increasing. Positive area. So if it's got an area of 8, it has to go up 8 from negative 8 to here. Well, that's 4. There's 8. So back here, it's got to be here. And it was going down and going up, so this has to be a minimum. It was going down, negative area, going up, positive area. This has got to be a minimum. It's got to hit here. If I go this way, if I just use triangles, if I just do this, that's negative 8 to 8, 16 by 4 in half. So 16 times 2, this whole thing is 32. So from here, I got to go up 32 by here. 4, 8, 12, 16, 20, 24, 28, 32. I got to be this high by 8. And there's more positive areas, so it goes up more. See, 8 to 12 is 4. By 4 is 16 and half, 8. Got to go up 8 more by 12. And it's going up, and then negative area, so it's going down, so it's reached a maximum. And then by 16, there's negative 8. 4, 12 to 16. 4 by 4 is 16 and half is negative 8. So I got to come down 8 by 16. Now let's continue back. We were to here. All this area is negative. 20 to 8 is 12. By 1 is 12 and half, 6. It's going to be negative 6. So it's got to come down 6 from 20. 16, 12, 14, 16, 18, 20. It's got to go from here. It's got to go down 6. So if I'm going back, I got to go up 4, 5, 6 by here. And the slope is 0 here, and it goes down to here. That's what it should look like.